class. This is part 2 of the chapter 13 review, and number 17, as you can see from here, a particle moves with the position function given at this point. The question is asked us to find the velocity and also speed, and last, acceleration. So we're going to try to do this one by finding derivatives. Now, since R has 3 components, as you can see, let us try to find the derivative of v of t. To find v of t, of course, we have to realize here that we have product rule which we have to obey, and that is equal to t times the derivative of ln of t, which is 1 over t, plus ln of t, right here, times the derivative of t, which is equal to 1 itself. So we don't have to worry too much after that. That whole thing belongs for I. Now, plus derivative of t to itself becomes simply 1, so we have j left. Now, in case of the last component, derivative of e to the negative k simply becomes negative e to the negative t. Okay, hence this portion will just simply drop out. We have minus e to the negative t. Okay, now that will be, in fact, our answer for velocity. So I'm going to write them up right here. And this first portion becomes 1 plus ln of t I plus j minus e to the negative t z. Oops. Okay. Alright, so let us look at the speed. In order for us to get the speed, we just, all we have to calculate is magnitude of this one. In other words, we just have to do 1 plus ln of t squared plus 1 squared plus negative e to the negative t has to be also squared. Now when you square them and then simplify everything, then this portion would have been something like this. Square root of ln of t squared from here, and then plus 2 ln of t, and plus we have 1 here and then another 1, which gives us 2, and at the end this negative sign will be cancelled out by square, as plus e to the negative t. That is the speed. Now, in order for us to get the velocity, the acceleration, we just have to find the derivative from the velocity. Now here we get 1 becomes 0, so we only have 1 over t left for I, and j becomes simply 0j, and then the lastly becomes plus e to the negative t. Okay, because the negative sign has been cancelled out by negative 1 from here as we take the derivative. Now, therefore, acceleration becomes 1 over ti, and j disappears, and then the last one would have been plus e to the negative t. Okay. Alright, so that was relatively simple for number 17. Then we will be going to continue. We'll be going to number 19 here. Now, here we realize when an athlete throws a shot at an angle of 45 degrees, now that means we are looking at something shooting out this way compared to the horizontal. That angle is 45 degrees. So we're going to look into this one a bit further later. Now, to the horizontal. Now notice that the speed is 43 feet per second, then in this case we're talking about 43 belongs right here. Now we actually have to find out the horizontal component and the vertical component, which will turn speed into the velocity through the angle of 45 degrees. So let us try to find that first. First, horizontal component of the velocity. In fact, horizontal component of the velocity will be 43, and then we have cosine of 45 degrees. And vertical component via y, in this case, happen to be the same kind of value because of the measure of the angle of cosine of 45 and sine of 45. Here we have sine of 45. Now, both of them in fact will be equal to then 43 over square root of 2, because cosine of 45 is 1 over square root of 2, or radical 2 over 2. However, we want to memorize over radical 2. All right. Now, 2 seconds later, what will actually happen? That is, in fact, since acceleration is negative 32 feet per second square, we know that the velocity would have been equal to negative 16t plus initial velocity. Now, in this case, we're looking at, I'm looking at the vertical component, so it will be Vy, which will be 43 over radical 2. Now, of course, in this case, height, I'm just going to call this one as height, becomes, we have to take the antiderivative of this one once again. But notice, when time was equal to 0, it was already 7 feet high. Therefore, our answer would have been this. This one would have been negative 8t squared. Oops, let us try to change this one just 1 second. I made a silly mistake here. Here we have 32, and here we have 16. Sorry for that silly mistake. And we will go back continually, having 43 over radical 2 t, and then the location, which was plus 7. This will tell us where the ball would have been, or the shot would have been, at t seconds after its release. Now, horizontally, what do I call that as? X of t. That simply is, since we have constant velocity in the x direction, it will be simply 43 over radical 2t. And that's it, I guess. That's basically what we can do. Now, 2 seconds later, then basically h of 2 is what we're looking at. Then we end up getting negative 16 times 2 squared plus 43 over radical 2 times 2 plus 7. Now that will be our answer. Now this becomes negative 64 plus, this becomes 43 radical 2, and this one is 7 in itself. So what is this approximately equal to? Sorry, I have to use the calculator. So what I'm going to do is this: by adding these two, we will end up getting 57. So in other words, I'm going to go to right here. (42) 43 radical 2 minus 57. Let's see what happens here. Oops. Instead of using the red, I probably have to use here square root. Then we end up getting about 3.1. So therefore, Horizontally, we are about 3.8 feet uh, above the ground. Now, horizontally, x of 2 becomes 43 over radical 2, and then times 2. Now we know this one to be 43 radical 2. So this one now, all I have to do is, and we get to realize it's about 60.8. Our answer is about 60.8 feet away from the first time you left the hand. Now, second, how high? In fact, how high will it travel uh, when the shot is uh, reaching its maximum point? We realize the velocity is equal to 0, so therefore b v of t is equal to 0. In other words, we have negative 32t plus 43 over radical 2. Now, if you have to solve this, we get to realize t is equal to 43 all thing over 32 radical 2. So let's try to find out what this is about equal to. So all I have to do here is simply multiply that by, or I can simply divide 14 by 32. And in fact, I will do it this way. 43 divided by 32 square root of 2 here. And our answer is about 0.95. Now, 0.95 here means 0.95 seconds per second later. Now let us go for part C. C is where does it land? Where it lands is basically based upon when the height is equal to 0. So that portion, C, when is the height equal to 0? Now that means we realize negative 16 t squared plus 43 over radical 2t, and then the last one was plus 7. So I'm going to try to go back to the Wolfram and find out what that value would have been here. So negative 16 t squared plus 43 divided by square root of 2 times t plus, I believe that was the equation. Let me just check it one more time. Yes. So we are setting it equal to 0. Then approximately it will be 2.1. So our answer here, t is equal to 2.1. But that we have to plug it into x of t, and t is equal to 2.1, then which is equal to about 43 over radical 2 times 2.1 would have been our final answer. So whatever you calculate this one, that would have been our final answer. We'll continue in part 3.